5 books on a shelf. Would anybody have any idea even how we would start to figure that out? Well, yeah, no, I'm talking about just lining them up, you know, just like, yeah, books on a shelf here. How would you...
Like A, B, C, C, D.
Yeah, how many different ways can we do that? Well, Lily? Well, we're just gonna put them all vertically, just like they are on a bookshelf over there. We're just gonna line them up. So let's think about this. Here's your bookshelf with 5 slots on it. Okay? And here's my pile of books right here. And I'm gonna set them on this shelf. So I reach down and grab a book out of my pile and I put it right here. Now, how many choices of books do I have for that first slot? Well, how many books are in the pile? 5. So how many do I have to pick from? 5. So I have 5 choices for that first spot. Now again, I'm not saying I'm putting 5 books in that spot. I'm saying I have 5 choices. I could put book A, B, C, D, or E in that spot. Okay? So I've grabbed a book and I've put a book in that spot. Now how many choices do I have for the second spot? Now there's only 4 left because I already put one in that spot. So now I have 4 choices. Well, how about for this spot? And then there's only 1 book left, right? And I'm going to multiply these together because I am putting a book here and here and here and here and here. And whenever I do an and situation, it's a multiply. So book 1 and book 2 and book 3 and book 4 and book 5, those are multiplied. Now, you could, on your calculator, just multiply, or in your head even, this is easy, multiply 5 times 4 times 3 times 2 times 1. You could do that. There is a special name for this situation, though. Jamal?
Factorial.
It is called factorial. 5 factorial. This is read factorial. And if you have your calculator out, here's what I would like you to do. I would like you to press the number 5 because we're doing 5 factorial. And then I want you to press your math button. And when you hit math, you'll notice across the top, you have different options at the top of the screen. Click over to prob, that's probability. And then do you notice once you get over there to probability, in your list, you have the exclamation point? So go down, click on that, and hit enter, and it will tell you the answer. 5 factorial is 120. So, your calculator will do factorials for you, but you could also just multiply them out individually. Now, kids, what if there had been 6 books in the pile instead of 5? How many ways could I have arranged 6 books? Huh? Yeah, how'd you get that, Zach? Yeah, so in other words, instead of 5 factorial, it would be 6 factorial. What if there had been 10 books? 10 factorial? So when you are arranging things in a line, if there are 10 of them, the answer is 10 factorial. If there's 12 of them, it's 12 factorial. So let's look at question number 2. How many ways can 9 people stand in a line? 9 factorial. 9 factorial. If you are arranging 9 people in a line, it is 9 factorial. What if we had 15 people? 15 factorial. When you are arranging things in a line, whether it's a bookshelf or people in a row, however many you've got, it's that factorial. Now, number 3. How many ways can prizes be awarded for first, second, and third place in a race with 10 contestants? And let's think about this for a minute. How many prizes are you giving away? 3. So first, second, and third place. So there are prizes. Somebody's going to win first place, right? How many choices do I have to give the first place trophy to? 10. So there are 10 choices for first place. Now I have given away first place. It's given away. So how many choices do I now have for second place? 9. And then for third place? 8. Now, that is not 10 factorial, is it? No, because I'm not giving a prize to every person. I'm only giving a prize to 3 of them. So that's 10 times 9 times 8. Now,
20 ways to do that?
Yep. And if you wrote them all out, I mean, you could, it would take forever, but you could write them all out and see that there are 720 ways to do it. Now we need to talk a little bit about, just a little bit of an aside here, and talk about the difference between that problem. So we had 10 kids, and we're awarding first, second, and third place. And you said the answer was 10 times 9 times 8, and you are exactly right. What if we had 10 kids, and we were giving 3 identical prizes? Now there's a difference here. Can you tell me what the difference is in the 2 problems? What's the difference? Here the prizes are all the same, and here the prizes were different. So it would be like me giving away 3 pencils, or me giving away a calculator, a pencil, and an eraser. Right? There's 10 kids either way, and I'm giving away 3 prizes, but these are different situations. I want you to think about this for a minute. If I'm giving away a calculator, a pencil, and an eraser, in that order, do you want to get picked first, second, or third if I'm giving away those prizes? First. You want to get picked first because you want that calculator, right? But what if I'm giving away 3 pencils? Do you care if you get picked first, second, or third? No. So in one situation, the order that you get picked matters, and in the other situation, it doesn't matter. So in this situation, order matters. And here, there is no order. Now, when order matters, we call that a permutation. Those of you with a calculator, I want you to go back to where you found your factorial button. You remember where that was? How did we get our factorial? We went to our math menu, and we clicked across till we got to prob, and then we just found the factorial. You should see in that column, I don't know if it's above the factorial or below the factorial, but you should see a button that says NPR. That P stands for permutation. So here's what I want you to do. I want you to go back to your home screen, press 10, then go to your permutation button. So math, prob, NPR. 3, enter. You may have to enter twice. Did you get 720?
Yeah.
This is 10P3. This is, you have 10 kids. You're going to pick 3 of them to get prizes, and the order that you pick them matters. So when order matters, we're going to use our P button on our calculator. If there is no order, it's called a combination. I don't know if you noticed or not, but right there by your NPR button was an NCR button. So press 10. Then go into your math menu across the prop down to NCR. 3, enter. And you're going to get a smaller number, and that number is 120. So 10C3 is 120. Now, the hardest part, the calculator does all the work for you. If you take the time to bring a calculator, it will do all the work for you. The hardest part is you have to figure out whether you're going to use your P button or your C button. And what is the difference? If order matters or not, okay? So let me give you another quick scenario. Let's suppose, and we'll get back to the sheet, but let's suppose that I had 20 kids in my class, okay? And I'm gonna pick a president and vice president of the class, or I'm going to pick a leadership team of 2. So in this case, I'm taking the 20 kids, and somebody's going to be president and somebody's going to be vice president. Here, I'm just saying, okay, you 2 are my leaders in my class. Now, do you see the difference between these 2 problems? In this case, do you care if you're picked first or second?
Yes.
Yeah, it matters, right? So this would be 20P2. 20 kids picking 2, but the order matters because you want to be president. Here, 2 of you are going to be the leaders. Does it matter whether you're picked first or second?
No.
So this one would be 20C2. If the order of choice matters, you're going to do a P. If it doesn't, you're going to do a C. We'll practice some more. All right. Let's see. That was 3. Number 4. Now this is a different kind of problem. Number 4. Here we go. Mrs. Ford has 8 jumpers and 10 shirts. How many different outfits are possible? This is a different kind of problem. I'm not arranging anything. I'm going to my closet, I'm grabbing a jumper, and I'm grabbing a shirt. How many different outfits could I come up with? 80. Beautiful. 80. Every jumper goes with every shirt. Probably not, but who cares, right? And so there would be 80. Mr. Ford has 5 sport coats, 12 shirts, and 10 pairs of pants. So how many outfits does he have? 600. And how did you figure that out? You're exactly right. How did you figure that out? 5 times 12 times 10. He goes to his closet. He has 5 choices of sport coats and 12 choices of shirts and 10 choices of pants. And anytime we say and, we multiply. So if I'm picking a jumper and a shirt, it's 8 times 10. If I'm picking a sport coat and pants and a shirt, it's all those numbers multiplied together. How many ways can the home row of the keyboard be arranged? Okay, now wait, this goes back to what we talked about at the beginning. It's a row. So how many, what'd you say?
9.
Yes, 9 factorial. Why did she say 9? Because there are 9 letters. It's like having 9 books. And we're arranging them, right? We're rearranging them in a row. So that would be 9 factorial. Beautiful.
This is fun.
Yes?
When you do 9 factorial, can you just say 9, like, exclamation mark, or do you have to, like, do it in the caption?
Well, it depends. 9 factorial would be the answer. Sometimes I'll ask you to actually come up with a number, and then you would give it that, whatever that number is, 3 million or whatever it is. All right, how many ways can you answer 10 true-false questions?
100.
20.
Okay, now wait a minute. Let's think about this for a minute. We've got 10 questions. Okay, so like here are the questions. There are the 10 questions. Now they're all true, false. So how many choices do you have for the first question? 2. How many choices do you have for the second question? Okay, are these all 2s?
Yeah.
Okay, so now we have to decide what we're going to do with all of these 2s. There's 10 2s. Now, are you answering question 1 and 2 and 3 and 4? Yes. So what do? If it's an and, we times. So this is going to be 2 times 2 times 2 times 2 times 2. So it's basically going to be 2 to the 10th power. When you are doing this and this, you times. So question 1 has 2 options, and question 2 has 2 options. That's 4, just for the first 2 questions. And then another 2, and another 2, and another 2. All right, now here we go. How many ways can 4 different prizes be given out if there are 10 people in the contest? Now wait, you got 10 people, and you're going to choose 4 of them to get a prize. So that is either going to be 10P4 or 10C4. So we have to decide 10P4. Why, Lauren? You are right. Why? Because they're different prizes. If the prizes are different, doesn't it matter what order I choose you? Now, what if they were identical prizes? Then it would be 10C4. Moses?
What's the math behind C?
The math?
Yeah.
10C4, for example, is 10 factorial divided by 4 factorial, 6 factorial. And the 6 comes from 10 minus 4. Well, we kind of did it. 10P3 is 10 factorial over 7 factorial. All right, number 9. How many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits? Okay, now wait a second. I'm going to draw a picture of this. What do these license plates look like? They have 2 letters followed by 3 non-zero digits. That's what the license plate looks like. Would you agree? Now, you're going to build a license plate. How many choices do you have here, Mary? 26. How many choices do you have here? Now be careful. Does anything in the problem say that you cannot repeat letters?
No.
So could we have a license plate that was BB?
Yes.
Yeah. Now, they may tell me in another problem, no repetition, but they didn't this time. So I'm going to say 26 for here too. Now, non-zero digits. How many non-zero digits are there? 9. 9, 9. Now, what are we going to do with these 5 numbers? We're going to multiply them. And we're going to multiply them, kids, because when I build this license plate, I have a letter and a letter and a number and a number and a number. And whenever I have and, I multiply. Now, Harry, look at number 10. It says we're going to do the same license plate, but nothing can repeat. So how is that going to change things if nothing can repeat? Well, this is still a 26,
25.
but this will be a 25.
9,
This is still a 9, but this would be 8 and 7, and we're going to multiply them all together because it says nothing can repeat.
So do you want us to multiply it together? Or
Yeah.
for now?
Yeah, yes, if this were a test or something, yes. I just don't want to take class time because a bunch of people don't have calculators, so. All right, how many 4-letter call signs are possible if every letter is allowed? What this means is like if you watch like WRTV or Wish TV, those are their call letters. So if you are allowed to use every letter possible, how many 4-letter call signs would be possible? 26, 26, 26, 26. What if you weren't allowed to repeat letters?
26, 25.
You're getting the hang of it. Good job. And you multiply those, right? Because you're picking letter 1 and 2 and 3 and 4. All right. Same one, but you can't have any vowels. So now we're picking a call letter 4. We're still going to have 4, but there are no vowels. 21.
20.
Well, now wait. It says the same as number 11, so that means we're allowed to repeat. We just can't have any vowels. So it would be 21, 21, 21, and 21. Now 14 says no vowels and no repetition. That would be 21, 20, 19, 18. No vowels and no repetition. Baseball team has 9 starters. How many different batting orders are possible?
19.
Okay, now wait a minute. I got 9 kids right here. And I'm going to line them up in a line. How many? 9 factorial. That's it, kids. It's 9 factorial. You have 9 kids and you're lining them up in a row, aren't you? Saying you're going first and you're going second and you're going third. That's 9 factorial. But what if the pitcher has to bat last? Eight factorial. It'd be 8 factorial. Because if the pitcher has to bat last, you're really only arranging how many people then? 8? Because you're saying, kid, you're last. So then I'm going to say, well, I'm going to do it the other 8, and that would be 8 factorial. What if the pitcher bats last and the best hitter bats third? That would be 7 factorial. Because aren't you just arranging 7 people then? You've pulled the other 2 out and said, no, you're here and you're here, so now I got to arrange all the rest of you. How many 1, 2, or 3-digit numbers can be formed using the digits 1, 2, 3, 4, 5, 6? Okay, this is a little bit tricky. Now, do you understand what's happening? You have the digits 1, 2, 3, 4, 5, and 6. And you're going to make a 1-digit number. Well, wouldn't there be 6 ways to do that? You either have a 1, or you have a 2, or you have a 3. I mean, there's only 6 ways to do that. Well, what if it's a 2-digit number? What if it's a 2-digit number? Now you're going to build 2 digits. And it doesn't say, now this problem's a little bit confusing, but it doesn't say we can't repeat. So let's assume we can repeat. So in other words, you could have the number 12, or you could have the number 66, or you could have the number 45. How many two-digit numbers would be possible? Well, how many choices do you have for the first digit? 6. And for the second digit? 6. So that would be a total of 36, if we allow repetition, which I'm assuming we are since it doesn't say we can't. Now what about three-digit numbers? Because the problem says we could have 1, 2, or 3 digits. What would 3 digits look like?
216.
6 times 6 times 6, or 216. Now, what you just decided is there are 6 one-digit numbers, there are 36 two-digit numbers, and there are 216 three-digit numbers. So how many numbers are there all together? What would we do? We don't multiply them, because we're talking about one-digit numbers or two-digit numbers or three-digit numbers. I want to know how many I have all together, so what am I going to do with those? I'm going to add them. If it's an or situation, you add them. When do we multiply? When it is a and. First digit and second digit. I multiply them. But in this case, you are going to build a one-digit number or a two-digit number or a three-digit number. So add them up. And that would be what, 258? All right, how many 5-letter words can be formed from the letters of the word Chevy? All right, now, I'm using the word words loosely, not real words, just letter combinations. Okay, so you've got 5 letters, right? And we're just going to line them up in different ways. So how many ways can we line up those 5 letters? 5 factorial. So the answer to number 19 is 5 factorial.
So how are we going to use, I guess I'm just confused on when we use P words. Like, and when it's like there's
Okay,
frequencies. Like,
if we have a group, like some stuff, and we're picking a subset out of it. So you have 6 kids and you're choosing 2 of them, then it will be 6P2 or 6C2. In this case, we're not doing that. We're taking all 5 letters and we're lining them up in a row. That's 5 factorial. Now, what about the letters of the word Precal? That would be 6 factorial. How many social security numbers are possible if all arrangements are possible? Do you remember what a social security number looks like? Now they're saying there's no restrictions. You can have any numbers, which we know is not really the case, but for this problem, that's what it says. That's what a social security number looks like. Now they're saying all arrangements are possible. So how many choices of numbers do you have for this first line? 10. Now everything is possible. No restrictions. Everything's possible. So how many would you have for this line? 10. And when you build the social security number, kids, don't you have to pick a number here and here and here and here and here? So what are you going to do with all those 10s? Multiply them all together.
When do you know to times them? Well, I know because the and, but when do you know when to put it like that and then when it's just a factorial?
Well, the only way it can be a factorial is if you are not reusing any of the, if you take, okay, if you had 10 numbers and you were going to line them all up in a row, that would be 10 factorial because you're not using any of the numbers more than once. As soon as you tell me that I can use them more than once, then it's not a factorial because then it's not going 10, 9, it's saying 10, 10. Okay? Now, how many telephone numbers in the 317 area code? So 317, there's a phone number, right? Now again, if you're allowed to use any number, how many choices? No, you don't have just 7 numbers here. How many choices do you have here? 10. Oh yeah, there's 7 total. So you have 10, 10, 10, 10, 10, 10, 10. So that would be 10 to the 7. That's why, kids, back in the old days when I was like your age, every household had one phone. Everybody, there's one phone number for a family. Now, look at it. Like, I got a family of, I have 4 kids, and my husband and I. So we have 6 phone numbers for our family. So that's why they just opened up some new area codes. I don't know if it impacted any of you, but they've had to create new area codes because they ran out of phone numbers. So they make a new area code, and then they have a new set of phone numbers. All right, now number 23. This is a new one. Now look up at number 20. All right, we already did number 20. What did we say the answer to number 20 was? 6 factorial. And how did we get 6? 6 letters in the word. That's exactly right. Now, look at the next one. How many letters are there in the word precalculus? 11. So when I say to you, how many arrangements are there of the word precalculus? You would say 11 factorial. And you would be right partially. What is different about this word that we didn't have to worry about in problem 19 and 20? Does anybody see it here? There's duplicate letters. They're called repetitions. There are 2 C's. Would you agree with me? Yeah. So I'm going to divide by 2 factorial. Those are my C's. Oh, wait, there's 2 U's. So I'm going to divide by another 2 factorial because of the U's. And there's 2 L's, so I got to divide by another 2 factorial because of the L's. So if all of the letters are different, you're good to go. If there's 8 of them, it's 8 factorial. But if you have duplicate letters, let's see, the word Mississippi is always used as an example. Then you've got, go ahead and count them. How many letters are there? 4, 5, 6, 7, 8, 9, 10, 11. There's 11. So we'd start with 11 factorial, because there's 11 letters. But 4 of them are S's. So I divide by 4 factorial, and that takes care of my S's. And 4 of them are I's, so I got another 4 factorial, that's the I's. And 2 of them are P's, so that's a 2 factorial for the P's. Okay, so, like my name is Lisa. How many ways can I arrange the letters in my name? 4 factorial. Easy peasy. My youngest daughter's name is Anna. She starts with 4 factorial, but what do I have to do? Divide by 2 factorial for the A's and 2 factorial for the N's. And you could do your name. You always start with the total letters, and then if you have repeats, divide. All right. Oh, okay, I just did 24. I forgot it was on there. I just did 24. All right. Number 25. Tell me why at least 2 students must have the first and last initial at Cathedral. How do I know absolutely that no matter what, somebody at Cathedral is going to have matching first and last initials? Now, not necessarily mine, but somebody out there in the school, 2 of them at least are going to match. How do I know that? Absolutely, positively, 100%. Okay, so if I look at first and last name, there's 26 times 26, right? And that would account for everything. That would be XX and ZZ and all the weird combinations. Well, what's 26 times 26? 676. So wait a minute. There are only 676 initial combinations. How many kids are active people? More than that. So if there's only 676 possibilities, but there's like twice that many kids, then somebody has to match, right? Yeah. Now, I'm not saying somebody matches you exactly. I'm saying there have to be people out there that match each other. All right, here we go. Number 26. This is what you two were kind of asking about. I have 20 kids. I'm on number 26. I have 20 kids. And I'm going to choose a president and a vice president. So I've got 20 kids and I'm picking 2. Does the order I pick them matter? So that would be 20P2. Now look at question B. Now I still have 20 kids, but I'm picking 2 people to be the council. 20C2. Look at 27. I have a club with 13 members, and I'm going to pick 4 to be the leadership team. 13C4. Because if you just are going to be on the leadership team, it doesn't matter where you're picked, right? You just want to be picked. But if I'm picking a president, vice president, secretary, and treasurer, that would be 13P4. Okay? Boy, we have packed a lot of problems into this period. So let me go ahead and give you your homework. It's in your book. I'll put it on school as your next period. But I'll write it down here for you now. Since you have a few minutes to start if you'd like.
No, I think it works. Yeah. I was freaking out.
All right, let's give this a shot, people. Why we have so many people absent?
It just doesn't work.